Hello everybody, welcome into another lesson. So today is part 1 of 2 of the binomial theorem. In this lesson we're going to use the binomial theorem to either find the coefficients of a term or a particular term without expanding the whole binomial. In the next lesson we will actually expand the whole binomial. But in this lesson, we're only concerned with using this theorem to find either the coefficient or find one particular term of the binomial expansion. So you have some arbitrary x plus y raised to the n power. Well, your first term is always to the highest power, to the n. You end up with your last term always being to the highest power. In between, what you have is, once you raise x to the highest power, your very next term will have some coefficient on your x and y term. What you'll do for your subsequent terms are, you will lower your x degree by 1 and raise your y degree by 1. And you'll continue this pattern until you get to x to the 0th, y to the n. That's how that works. Now, to find a coefficient of a term, it's going to be the combination of n things r at a time. So this is why I taught yesterday how to find combinations of so many things, taking so many things at a time. You have this formula for combination, n things r at a time, n factorial over r factorial times n minus r factorial. So r is always one less than the term number you desire to seek. The reason for that is this. It's always because a binomial has n plus 1 terms. So r is considered, it's always found for n minus 1 to balance everything out. So you actually get the nth term that you seek. So if I had this to the 11th power, there would be 12 terms. And to find a particular term, you of course need to find the coefficient times, in this case, x to the n minus r power, and then y to the r, where again r is one less than the term number you desire to seek. But no matter what term you're on, if you take the sum of your x and y powers, they should always equal n. They should always equal n. So that's how you'll know you're on the right track. Now, I know this seems scary, but it's really not that bad. We will go ahead and do some examples here. First, we're actually going to start with finding a whole term. So let's go ahead and do that. Let's say we're given something like x plus 8 raised to the 10th power. They want us to find the fourth term. So we are to find the fourth term. Before we do that, let's identify some things here. Remember how I said r is one less than the term number you're on. So that means my r is going to equal 3. Alright, now, n is always the power of that the binomial is raised to. Those two things you need. You need your r and you need your n. So that means my n is 10. And my r is 3. Okay, so now that we have n and r, we can set this up. Let's focus on just finding the initial coefficient. So if I take the coefficient, if I want to do that, I have to take the combination of those 10 things 3 at a time, because it's n things r at a time. Well, that of course is going to equal 10 factorial all over that 3 factorial times 10 minus 3 factorial. Well, let's simplify this then. You'll have 10 factorial all over 3 factorial times 7 factorial. Well, this could simplify even further into 10 times 9 times 8 times 7 factorial all over my 3 factorial, which is really 3 times 2. And we could put times 1, but we don't need to. Times the 7 factorial. Okay, well, notice your 7 factorials are going to cancel out, right? Now 3 goes into 9 3 times, so your 3 will cancel out in the denominator. This 9 will turn into a 3 in the numerator. And then, well, 2 goes into 8 4 times, so that 8 could turn into a 4. So what you really are left with here is simply 10 times 3 times 4, which would give you 30 times 4, or 120. Now, that's only the initial coefficient. This isn't going to be the actual full coefficient. The reason being is because you have this 8. That's going to affect your overall coefficient of what the actual term is. But we at least have a start here. Now we're going to take the formula to find the actual term. We'll take this 10 things 3 at a time, so that would be 120 times, it's always going to be my first term of the binomial, that x raised to the n minus r power, in this case the 10 minus 3 power, and then it's going to be that 8 raised to the r power, which is 3. So let's go ahead and really find this. So you'll have 120 times x to the 10 minus 3, that's x to the 7th, times what is 8 to the 3rd. That's going to definitely be a big number, right? Let's find 8 to the 3rd. That's 512. So let's go ahead and multiply 512 times 120. You get 61,440. So the real coefficient is 61,440 x to the 7th. So the fourth term of this particular binomial expansion total is 61,440 x to the 7th. And I did that by first finding my r to be 3, which is always one less than the term number I'm on. The n is always the power the binomial was raised to, so I take the combination of 10 things 3 at a time. I get my initial coefficient, and then I take my two terms, the first term always to the n minus r power, and then my second term always to the r power, multiplied together, and in total I got a fourth term of 61,440 x to the 7th. And I got some more of these. Good one. So we have x minus 5 raised to the 6th power. We got to find the 7th term. So we're going to find the seventh term in this case of this expansion x minus 5 to the sixth power. And yes, we are going to have a seventh term because remember, the number of terms of a binomial expansion is always the power it's raised to plus 1. So you have 6. This is raised to the sixth power, while 6 plus 1 is 7. So yes, we can find a seventh term. Now, remember, there are two things we need to find. First, your n, that's always the power that this expansion is raised to, n, that's 6. And then you have your r, which is always one less than the term you desire to seek. Well, r would be 6 in this case, since we're looking for the seventh term. Now let's go ahead and find the initial coefficient, which would be the combination in this case of 6 things 6 at a time. Well, that's going to be the same thing as 6 factorial all over 6 factorial times 6 minus 6 factorial. Well, notice your 6 factorials can cancel out right away. You'll just end up with 1 over 0 factorial, which we know 0 factorial is 1, so you'd have 1 over 1, which would just be 1. So now just take this combination piece. You have 1 as your initial coefficient times, take your first term of your binomial expansion, that x, it's always raised to the n minus r power, so that would be to the 6 minus 6th power, times now take your negative 5, and remember this is a negative 5 in the binomial expansion. You could treat this as plus negative 5, but you do have to consider the whole negative, raised to the r power, which is 6. Well, 1 times anything is itself, so the good news is we don't even got to deal with that 1. But we do get x to the 0 times negative 5 to the 6th. Well, x to the 0 is also 1, right? So we're simply left with negative 5 to the 6th power. Well, we should get a positive term because you have a negative number raised to an even power. So let me just take that negative 5 raised to the 6th power. You get 15,625. So that should end up giving you your seventh term of this binomial expansion should be 15,625. Let's do a couple more of these, and then we're going to find the coefficient of a particular term. All right. So let's say I have something like 10x minus 3y raised to the 12th power. So we're going to take 10x minus 3y raised to the 12th power. We're going to find the ninth term. So they want us to find the ninth term of the quantity 10x minus 3y raised to the 12th power. Well, first, once again, we need two pieces of information. We need our n, which is always the power of that the binomial's raised to. That's the 12th power. Your r is always one less than the term you desire to seek. So if we're going for the ninth term, that means r has to be 8. Now that we have those, we can start by finding the initial coefficient, which would be the combination of those 12 things, 8 at a time. Well, let's go ahead and do that. So we'll have 12 factorial all over 8 factorial times 12 minus 8 factorial. Well, this could simplify then into 12 times 11 times 10 times 9 times 8 factorial all over 8 factorial times 4 factorial. Well, some good news here is that the 8 factorials are gone, but let's take care of what's left. So now you have 12 times 11 times 10 times 9. Now what is 4 factorial? That's 4 times 3 times 2, and then we could really do times 1, but that's not necessary. Well, 4 times 3, if you multiply those are 12, right? Those will both cancel into 12, and then 2 goes into 10 5 times, so we completely abolish the denominator. What you're really left with is 11 times 5 times 9, which would actually give you 495. So the initial coefficient is going to be 495. Well, let's go ahead now and let's find the whole term. So we'll take that NCR piece, which would be that 495, times my first term. So you have to take the whole 10x term, that whole 10x, and raise it to the n minus r power. In this case, that would be 12 minus 8 power, times my second term, that negative 3y, raised to the r power, which in this case is 8. So this is going to simplify into 495 times the quantity of 10x raised to the 4th power times that negative 3y raised to the 8th power. Well, let's go ahead and actually take the powers here. So you'll end up having 495 times, let's take that 10x to the 4th. Well, 10 to the 4th is 10,000. So you would end up having 10,000 x to the 4th times, you'll take that negative 3y to the 8th. Well, we got to take negative 3 to the 8th power. That's not going to be fun. That would give you 6,561 times y to the 8th. And now we just need to multiply the numbers, the coefficients, times this coefficient, times your variables. You'll have the whole term. So let's go ahead and find this bad boy. So it's hideous. You end up with 32,476,950,000 x to the 4th y to the 8th as your 9th term. So the 9th term of this binomial expansion is going to be 32,476,000. 32,476,950,000 x to the 4th y to the 8th. And your real coefficient of this term would be that 32,476,950,000. That would be your true coefficient, because you got to consider the coefficients of the variables raised to their powers times the combination. So that's really your true coefficient. All right, let's do one more of just finding a term, and then we're going to change it just a little bit. Now, we're going to throw this at you. What if we had 7x squared plus 2y raised to the 15th power where they want you to find the eighth term. Okay, so we have inside the parentheses, the x term is not even linear, it's quadratic. What that means is we have to take the whole 7x squared raised to a power. So they want us to find the eighth term of the quantity 7x squared plus 2y raised to the 15th power. Well, we need the n and the r first. The n's always the power the binomial is raised to. That's going to be 15. Your r is always one less than the term you seek, so we're seeking the eighth term, meaning the r has to be 7. Alright. Now, at this point, we can find the starting coefficient by taking the combination of those 15 things, 7 at a time. Well, that of course would equal 15 factorial all over 7 factorial times the quantity of 15 minus 7 factorial, which is going to then equal 15 factorial all over 7 factorial times 8 factorial. And now here comes the fun part. So to start with, we'll have 15 times 14 times 13 times 12 times 11 times 10 times 9, and we can stop at 8 factorial. All that divided by 7 factorial times 8 factorial. Well, good news is we can cancel out the 8 factorials between the numerator and denominator. So you're left with all this over 7 factorial. Well, let's expand the denominator to get a feel for what 7 factorial is. So in the numerator, you'll just have 15 times 14 times 13 times 12 times 11 times 10 times 9. All over your 7 factorial, which is 7 times 6 times 5 times 4 times 3 times 2, and really there's a default times 1 that we don't need to put. Okay, well, what do we know here? We can actually take 5 times 3, cancel those out with 15, get rid of the largest term in our numerator. So the 15 disappeared. We even know that 7 times 2 is 14, right? So we could take that 7 and 2 and cancel those with 14. Alright, so what do we have left now? We just have a 6 and a 4. Well, let's get creative. 4 goes into 12 3 times, right? So that 12 can turn into a 3. Now you just have this loose 6 in your denominator. Well, isn't 3 times 10 the same thing as 30? And 6 would go into that 30 5 times. So the 10 and 3 will be gone. We'll just have a times 5. And the 6 is gone. We should always end up with a whole number in the numerator, and then the denominator should disappear. So what we're reduced to is 13 times 11 times 5 times 9. Much better to work with, right? Let's see what our starting coefficient is here. So 13 times 11 times 5 times 9, that is 6,435. So we got the combination of 15 things, 7 at a time, is 6,435. Now we need to take that to find the actual term. We're going to take the whole 7x squared your whole first term raised to the n minus r power, that would be to the 15 minus 7 power, times my second term, that 2y, raised to the r power, which is the 7th. Alright, so let's go ahead and do this here. This is just going to simplify into 6,435 times that 7x squared, that whole quantity raised to the 8th power, times that 2y raised to the 7th power. Now we'll actually go ahead and apply the powers. So we'll still have that 6,435. Now take that 7x squared raised to the 8th power. First we start with 7 to the 8th power. That's a big number. That gives you 5,764,801. And then if we take x to the second to the 8th power, you just multiply the exponents. That would be x to the 16th. And then we need to take 2 to the 7th, 2y to the 7th. That's just 128, so you would have times 128 y to the 7th. Now we go ahead and multiply everything. So start by multiplying the coefficients on your variables and the coefficient outside of the parentheses, and we're going to have another really horrendous number. Alright, so 6,435 times 5,764,801 times 128. Are you ready for this? We get 4,351,287,680 x to the 16th y to the 7th. That would be your entire 8th term. So the coefficient of the 8th term is 4,748,351,280. Wait, 4,748,351,287,680. That's just your coefficient, and the whole term is that coefficient times x to the 16th y to the 7th power. Okay, so that's basic finding terms. Now you might have another type of problem you're going to see. Okay, so let's say you're given x plus 3 raised to the 12th power. They want you to find the coefficient on the a to the a times x to the 4th term. They want you to find that coefficient a on the x to the 4th term. Well, what do we know here? We know for sure that n is 12, right? N equals 12, so you always start out with your n. Now, since x is your first term, x is really your first term of the binomial, it's always raised to the n minus r power, right? Well, we know that n minus r equals that 4, which means that 12 minus r equals 4. So what does that really mean? That means in this case that r is going to equal 8. So we found our r by using the fact that x is the first term, and the first term is always raised to the n minus r power. The first term is in a binomial expansion, and we solve for r. Now, to find the true coefficient, we start out like we did in the last problems. We're going to take the combination of those 12 things, the n things, r at a time. In this case, it's 8. So you'll get 12 factorial over 8 factorial times the quantity of 12 minus 8 factorial, which is going to then give you, of course, 12 factorial over 8 factorial times that 4 factorial. Well, the numerator, you'll have, of course, that 12 factorial is the same thing as 12 times 11 times 10 times 9 times the 8 factorial, all over 8 factorial. Now 4 factorial will expand, right? That'll expand into times 4 times 3 times 2. We don't need to do times 1. Well, the 8 factorials will cancel out. 4 times 3 is definitely 12. That'll cancel into the 12 in the numerator. And then 2, that goes into 10 5 times. So we could turn that 10 into a 5. You're left with a simple 11 times 5 times 9, which would give you 495. Alright, well, in order to find the coefficient, you still have to really find the term. You have to find the whole term to be able to solve for the true coefficient of that x to the 4th term. So what you're going to do now is take that combination of 12 things 8 at a time, the coefficient we just found, the 495, times our x. In this case, it's just 1x, so x raised to the n minus r power, which we determined to be 4, times that 3 raised to the r power, which is 8. Well, we're going to take 495. We could even say the x to the 4th at this point, but we need to take that times whatever 3 to the 8th is. So 3 to the 8th is 6,561. Now we just do the multiplication. We should end up having our answer for what that coefficient is. And you end up getting 3,247,695 times that x to the 4th. So that means that a is just the coefficient on the x to the 4th term. That means a equals that 3,247,695. That would be your answer for the coefficient on the x to the 4th term. A very large coefficient, but that's exactly what it is. Let's do 2 more. We're going to actually do 2 more. We're going to do this. So we're going to have x squared plus y raised to the 10th power. They want us to find the coefficient on the x to the 8th, y to the 6th term. Well, hang on a minute. You're probably wondering, what the heck are we doing? Well, if you add these 2 powers, you get 14, which exceeds the actual number of powers that the binomials raised to, right? Because 8 plus 6 is 14. However, look at your binomial expansion. Look at your binomial itself. That's an x squared in there. What does this really mean? What this means is we're going to take a times that x squared. Now, x squared to what power gives us x to the 8th? That'd be to the 4th power, right? And then you'll have your y to the 6th. So we want to find the real coefficient on a times the quantity of x squared raised to the 4th power times that y to the 6th. So that's how you would separate out, really, if you just look at the original binomial, you would be able to get what the actual term is raised to. So it's not as intimidating as it looks. Now, how are we going to go about this? So we know the y term is always raised just to the r power, right? The r equals 6. Well, we know n is 10. And then, of course, the first term is always going to be raised to the n minus r power. Well, 10 minus 6 actually gives you 4, so that checks out. First thing we want to do, again, is find the initial coefficient. That's going to be those n things r at a time, or 10 things 6 at a time. Well, that's going to equal that 10 factorial all over 6 factorial times the quantity of 10 minus 6 factorial, which would turn into 10 factorial all over 6 factorial times 4 factorial. Well, that 10 factorial, that'll change into 10 times 9 times 8 times 7 times 6 factorial all over 6 factorial, and then we can expand out the 4 factorial into 4 times 3 times 2, and really there's a default times 1 that we're not even going to write. Notice your 6 factorials cancel out. Okay, well, guess what? 4 times 2 goes into 8, right? We can cancel both 4 and 2 in the denominator with the 8 in the numerator. And then we just have that 3 goes into 9 3 times, so the 3's gone. That 9 can turn into a 3. So what we're really left with is simply 10 times 3 times 7. Well, 30 times 7 is 210. So we're going to actually have now 210 for the combination of 10 things 6 at a time. So take your coefficient of 210 times your x squared raised to the 4th power times that y to the 6th, which would end up giving you 210 times, well, x squared to the 4th power is x to the 8th, and then you have y to the 6th. And what do you know? We have it now in the form of a x to the 8th, y to the 6th. So that means my coefficient, which they wanted, that a equals 210. That would end up being my coefficient on the that would be my coefficient on my x to the 8th, y to the 6th term, where a is 210. And let's do one more. Okay, so we're going to take z squared minus 1 raised to the 12th power. They want us to find the coefficient on the a z to the 6th term. Alright, so they want us to find the coefficient of that z to the 6th term. Well, keep in mind, the first term in the binomial is actually z squared. So that means we're going to have a times z squared quantity raised to whatever power gives us z to the sixth. Z squared to what power gives us z to the sixth? That would be to the third power, right? So really we're finding the coefficient on a times that z squared raised to the third power. Alright, so we don't have a real obvious what the power on -1 is in this, do we? Well, we know that n total, that's the power this is raised to, is 12. N is definitely 12, right? Z squared is part of the first term. The first term is always raised to what? The n minus r power. Well, that means that n minus r, or 12 minus r, is really going to be equal to 3, because that z squared is raised to the n minus r power, so that means r equals 9. So we just now found r. Let's go ahead and solve for the initial coefficient. We can do that by taking those 12 things 9 at a time. So that's going to give us 12 factorial all over that 9 factorial times 12 minus 9 quantity factorial, which would give us 12 factorial all over 9 factorial times 3 factorial. Let's go ahead and simplify this a bit. So 12 factorial is the same thing as 12 times 11 times 10 times 9 factorial all over that 9 factorial. And we can expand out that 3 factorial just into 3 times 2 times 1, or 3 times 2. Now notice your 9 factorials cancel. 3 times 2 is 6, which goes into 12 twice. So 3 times 2 is gone. That 12 will simply turn into a 6. So now you're just left with 6 times 11 times 10. Well, 6 times 11 is 66 times 10. That's 660. So you start out with an initial coefficient of 660. So now take your coefficient times that z squared, which is raised to the third power, and then we know the second term, the -1, would just be raised to the r power, so that would be 9. This would be times -1 to the 9th. Well, good news is we have a -1 raised to a power. Since -1 is raised to an odd power, that means this will just be negative. So this would actually turn into -660. And then z squared to the third is z to the sixth. Now we have this in a format of az to the sixth, where you have the coefficient on the z to the sixth term. So that means the coefficient of the z to the sixth term is -660. So there's your coefficient of -660. Okay, so that's it for this lesson. Next lesson's going to be the binomial theorem part 2, where we actually expand binomials to powers. But the good news is there's 2 pieces of good news. One, we're not going to go this high in powers. The craziest we're going to get is maybe the 5th or the 6th power for expanding the whole binomial. And then 2, there's actually a shortcut as opposed to applying this whole theorem, which it's based off the theorem, but there's a shortcut instead of trying to take the combination of so many things at a time for every single term. So I hope everybody has a great day. Take care.